Hello everybody, this is Mrs. Ellsworth again. This is the last video of this unit, and it just so happens that it's going to be tying together everything we've been talking about so far. But let's go ahead and get started. These are the 4 different parts of SI units that we'll be talking about. But what does SI stand for? SI stands for the International System of Units. It is a metric system, and it is used in science, industry, and medicine. Lots of people think that the metric system is not really used in the United States, but it is. And in these 3 industries, science, medicine, and industry, it is used quite a bit. Have you ever heard that you're going to get so many cc's of medicine? Well, cc stands for cubic centimeters in the medical field, and otherwise we would have a cm with a little exponent of 3 in science. So we do use it. It's just that it's not for the basic public. They don't use it a whole lot. Well, let's go ahead and move forward. SI units, the international system has base units, and these base units are stored like we have a kilogram mass in the United States that is a copy or a very similar copy of the big one in France. We also have a meter stick. Anyway, these are the actual units that we have that are identical to other countries, so that we all know what each other is talking about, so that we can understand when a doctor talks about so many cc's of medicine cures this problem, we know what a cc is. So that's why it's important to have this international system of units. But these are the base units. Here is a picture of a kilogram, and I think that's kind of funny. I was reading this in Popular Science, and he says that it's a ridiculously precise standard that is a copy of what they have in France, but that they're talking about, think of the most fussy science teacher you've ever had, the one who docked your grade if you were a 1/6 of a decimal place off in your answer. Anyway, this right here is about that far off too, and it's really precise, and this is one of those international systems of units that we use to make sure that we are communicating with other countries the same exact quantity. Here is the prototype meter bar of the United States. So this one right here, note there's a reason why they have it shaped like this, and it has to do with how things can bend, and so this right here is made in a way that it won't bend or anything like that. Anyway, back to these different units. They are just regularly measured straight out. You just take a method of measuring them, and they are just measured straight out. There are other units too that are derived units. And derived units, you notice that I have to make 2 measurements to find area. Okay? And then I have to multiply them to find area. And in volume, I have to take 3 different measurements, the length, the height, and the width of it. And so this one I have to make 3 different measurements, and then I have to multiply it. And then density, if you remember right, we had to mass it, and then we had to find the volume by water displacement, and then we could divide those 2 measurements. So what do these 3 things, area, volume, and density, have all in common? They are derived. We had to use some type of a mathematical operation to come up with those units. We had to use a math operation to get those units. Okay, here are some SI derived units. Area, of course you know that one. You've got square meters because you had to take a meter times a meter. Volume, you had to take a meter times a meter times a meter. Okay, in speed, it's distance per time, so it'd be meters per second. It could also be kilometers per hour, but the SI unit is meters per second. Okay, acceleration is meters per second every second. And then for some of you deer hunters, or I guess we should just say hunters who have those strong flashlights that are measured in candles, you would understand this. That talks about how much there is per square meter going out. Mass density, the SI unit for it is kilograms per cubic meter. Of course, we have been using grams per cubic centimeter or milliliter. Okay, moving on to the next subject, scientific notation. This should be a review from your other math classes and perhaps science too, but this is just a reminder that you'd go from your decimal spot where it's at, okay, and you're always going to place it right after the first non-zero digit, so it goes right here, not over here or here. So if you would move that decimal to the 9.8, the 9.8 right here, how many times would you move it? Well, you would move it 5 times to the right, and so it gets a -5. The negative values right here show that it's a very small number that's smaller than 1. Okay, let's look at the next example. If I was going to take this decimal and move it to the first, right after the first non-zero digit, so it's going to be a 6.5 something. Okay, how many times did I move it? I would move it 7 times. So we do 6.5, because that's where we move the decimal to, 6.5 times 10 to the 7th power. One of the ways that I will trick you on a test is I might have 65 times 10 to the 6th power, and then that would be wrong because it always has to go right after that first digit. Oopsie. Moving on. Didn't realize I was moving on, but here you can stop this, quiz yourself. I'm going to take a second here and then I'll expose all the answers, so stop it and pause for a little bit. Okay, if you have any questions, I really want to hear about them tomorrow in class, because sometimes we think that we know of things and then we get a few surprises, and you're not the only one. So let me know, or else come see me in the morning if you have any questions on scientific notation. Accuracy and precision we talked about earlier this year when we were learning how to measure. And accuracy is when we are right on to the actual value, and you are as close as possible to the actual value. And precision is just a little bit different. Lots of times students have troubles with these two, but precision has nothing to do with being right on or close to the actual value. What this is like if we go and measure the same thing, and I and my 2 partners, we get the same exact measurement, then we've repeated the results 3 different times. That is precision. You know that we've also talked about precise tools too, so there is also another way of checking for precision too, and that's by using an instrument that is more precise. Remember, it has more decimal places. Let's look at this picture just a little bit better. Notice that the beaker only can be measured to the ones. 25 is what it's estimated, could be plus or minus 1. Notice that this graduated cylinder is about 25, and then we still can't quite tell. It's about 25.2, but it could be up or down 1. Okay, and then here's a burette, and you haven't seen one of those yet. We will be using one later on this year. Anyway, this one right here is, you've got to read these ones upside down, so watch out. Anyways, this will be 25.2. It is almost at the 3, so it's 25.28, and then you plus or minus the last one. This one is the most precise because it goes out the most decimals. Okay, it is the most precise. So precision is repeated results, and also the highest amount of decimals, and accuracy is how close you are to the actual value. You can be precise and not be accurate, and you can be accurate and not precise. Here are some examples. Okay, I've got these targets here. The actual value, we would say, would be right in the middle. Okay, so when you look at the very first one, do you think it is accurate? Do you think it is precise? When you go and you take the average of the results and they come right to that bullseye, that would be accurate. But it is not very precise because you notice that you didn't get similar results. You got a whole bunch of crazy ones. So this one has low precision and low accuracy because it's going to be averaging over here further. So it is not going to be right on the target. Okay, the next one. Okay, down here, it probably is going to average close to the bullseye, isn't it? So this right here has got a nice grouping. Okay, it's got high accuracy, but it's not super duper close for precision. And I accidentally told you this one up here. It has got low accuracy because it is not close to the actual value at the bullseye, but it's got a very strong cluster right here. So this one is high precision and low accuracy. Okay, and then the very last one, you notice we've got a tight cluster here, and it's right at the bullseye, so the average is going to be there. So what do you think this one is? I'd say it's both high accuracy and high precision. Okay, just a reminder that we did cover all of these. We talked about base units in the SI system, and also measured unit and a derived unit. The derived one has to have calculations. We talked about scientific notation and accuracy versus precision. The rest of this video will be all on checking how well you measure with graduated cylinder, thermometer, and also ruler. So you can practice if you'd like to. Just quiz yourself, and I'm going to tell you the results of each one of these. So as soon as you see it, pause it so you can take the measurement. If you stop here, I will see you tomorrow. But going on. Okay, this one I read at 9.03 milliliters. This one is not quite up to 36, so it's going to be 35.9. Remember, you can plus or minus that last digit, so it could be 36.0. It could also be 35.8 milliliters. Okay, this one is a little bit over the 6.2, so it's going to be 6.23 milliliters. This one is just shy of 5 milliliters, so I'm going to say this, 4.98 milliliters. Okay, we're measuring the green paper. Where does it go to? So we're going to try and estimate where this one right here by reading between the lines. And so that'd be about 29.13. Here is 74.42 centimeters. Okay, here is 60.32. I know a lot of people would say it was 63.2, but you know 63 is further out here. So it is 60.32 centimeters. Okay, and here are two thermometers. I got 90.4 and 21.7. Those are all degrees Celsius. Okay, and then the last two, I got 55.5 degrees and 42.1 milliliters. You can go back and check those as much as you want to and quiz yourself even right before we take our test. That's the convenience of this. I'll see you tomorrow in class.